Hey guys, today for our physics video lab report we are going to talk about projectile motion. But what is projectile motion? Projectile motion is the motion of an object thrown near the Earth's surface. The path of this motion is curved due to the gravity of Earth acting as a downward force for the object. In calculations concerning the motion of a projectile, air is mostly neglected as to keep gravity and the initial force the only types of forces that could affect the projectile. Also, it would simplify the equations which will be used in calculating the projectile motion. But now, we try to put air in the mix and see whether it will or will not have an effect on the motion of the ball. Disclaimer, the air resistance that would be included would be that of the common air resistance we have, and not uniquely powerful ones that happen in bad weather or the like. Also, the mass of the ping pong ball is 2.7 grams. Now, to do the experiment, we would just look at the video and use our observation skills and look if the parabolic track of the ball is changed or altered by the presence of air resistance. So now, we will first track the video of two table tennis players and gather the results as well as observe the trajectory of the ball. So let's start tracking. The position of our x-axis is parallel to the flat of the table, and as we position it, the y-axis would follow suit. The origin would be the point when the ball bounces off the left side of the table, and the calibration would be 4 centimeters. Based on the ball's diameter. As you can see in our tracked video, the ball maintains its parabolic way and it looks as if there's really no change from a freer environment and an air-filled one. We take a look at the data we gathered from tracking the ping pong ball during its flight. It can be seen that the horizontal velocity of the ball, Vx, was somewhat altered, however only minimal, but it still affected the speed. Next, we look at the vertical velocity, Vy, of the ball. Here, we can see that the trend of the velocity is normal, with its velocity going down as soon as the ball bounces off, but we see that the acceleration of the ball is different than that of gravity. Lastly, the time and the range the ball traveled would not be that similar, since both velocities were affected, albeit minimally. With this data, we can conclude that this oversimplification is only acceptable in cases when the object is large enough that it can neglect the drag force of the air in the environment. Yes, the change in velocities, time, and distances all appear non-existent, but for one to really know the most accurate time or speed an object comes through in real life, air resistance needs to be involved. Although, because of its ranging effect mostly minimal, it is acceptable that it is neglected on the purpose of simplifying for discussions, but not really that reliable when it comes to real-life situations. So all in all, we recommend that you involve air resistance when calculating the motion of a projectile when you want your data to be accurate as possible. But it is still not entirely wrong to neglect it when you're just going for the estimate. That is all for this video report. Leave us your comments below. I am Matthew Manalo, and with my group partners, River de Guzman, King Arthur Santos, Gaba, and Millan, we thank you for watching and see you next time.